Introduction. And hello, everybody. Thank you all for being here. As always, it is an honor and a privilege to be here. I don't know about you, but like after 2 days of this, my brain is so full of incredible stuff. I feel like brain overload. But I'm hoping you'll indulge me. I know we just saw a lot of code there from Aaron's fantastic talk, but I would like to show you some code. That's okay. Is it okay if I show you some code? Yeah? Okay. All right. Oh, yeah. Ready for it. Ready for some code. Here's some code. This is actually a photograph of code. This is a photograph of DNA. It's the famous photograph 51 taken by Rosalind Franklin, the X-ray crystallographer. Literally a picture of code. Now, this code base isn't the binary code that we're used to, ones and zeros. This is a base 4 code, deoxyribonucleic acid, or DNA. Right? Adenine, cytosine, guanine, thymine, the 4 bases of DNA. And you can see in Rosalind Franklin's notebook that she begins to figure out the code base of life itself, of DNA. And from these 4 very simple building blocks, we get all life on planet Earth, which is kind of incredible. You, me, everybody in this room, every human being on the planet, but also every mammal on the planet, every bird, every reptile, every fish, every insect, sharing the same code base, the base 4 code base. So there's this enormous variety in life on our planet. And yet there's also some commonalities that you can see as you look at the different species. There's these trends in life, a trend towards specialization, that life evolves to be very good at doing one thing. A trend towards ubiquity, that life finds a way. And this trend toward cooperation, this is an interesting one, when the sum of a species' activities can be greater than the individual. And we're no different. If you look at the trend of Homo sapiens, we've trended towards specialization, ubiquity, and cooperation. And this way that life evolves, it works really, really well, but it's fairly slow, this process of evolution through natural selection. It's remarkable, but it takes time because it relies on selecting errors, effectively, that happen in reproduction. Now, the one thing we do have that's slightly different to every other species on the planet is we found a way to bypass this evolution through natural selection. We found a way to give ourselves abilities without having to go through that long, slow process of evolution. And that's through technology. We found a way to augment ourselves, to augment our abilities, to specialize without having to wait for that long, slow evolutionary process. So this is an Australian hand axe, a very old piece of technology, a sharp cutting tool. We didn't have to evolve a sharp limb at the, to do the cutting. We were able to use technology to get the benefit. And that then has an effect on how we as a species evolve. Right? We shape our tools, and thereafter the tools shape us. So the Australian hand axe is a very old piece of technology, but it's kind of a very typical example. If we look at a newer piece of technology, it's augmenting ourselves, something at the end of our hands to be able to draw. This is a pencil, as you know. One of my favorite pieces of technology. I think it's absolutely wonderful. It's got a very clear affordance, and that pointy bit in the front is pretty clear. That's the bit you use. It has an undo at the end, very useful. And it has a built-in progress bar, which is good. And what's interesting is if you look at the trend of technology and you compare it to the trend of biology, you start to see some commonalities. You start to see the same trends towards specialization, ubiquity, and cooperation. So a pencil is really good at one thing, and a Australian hand axe is really good at one thing. Ubiquity, you can find pencils all over the world, all over the planet, pretty much the same form factor. And cooperation, that's where it gets really interesting with technology. In fact, there's a book called I, Pencil by Leonard Reed. It's told from the point of view of the pencil, I, pencil. And the whole point of the book is to point out that nobody can make a pencil, as in no single person can make a pencil. It requires cooperation, right? You've got to get the wood. You're felling the trees to get the wood. You've got to get the graphite, putting it together, right? You have to have some kind of division of labor to make it work. So division of labor is kind of core to technology. So cooperation really is required when it comes to to technology. You can try to create technology entirely by yourself, but you're probably going to have a bad time. There was the instance of Thomas Thwaites. He's an artist in England. You might have seen his most recent project where he tried to live for a year as a goat. But this is one from a while back where it was called the Toaster Project, and he attempted to make a toaster from scratch, like literally from scratch. He wanted to make the plastic, he wanted to do the wiring, you know, he wanted to mine the metals that were used. It was prohibitively expensive to do this. And it worked for like a second before it fused. As you can see, it doesn't really pass muster. So cooperation really is key. And like I said, when you compare biology and technology and you start to see these commonalities, you'd be tempted to think, oh, it must be the same process at work. But actually, they're very different. Like I said, with biology, it's evolution through natural selection. And we happen to end up with the current state of biology, right? We like to think that we're the most highly evolved species on the planet. But the truth is that every species that's still alive on the planet is the most highly evolved species for its environment. The fact that it's still around is the proof that it's the most highly evolved. So nature doesn't plan a species, right? Nature doesn't imagine an elephant or an ostrich or a fish and then work towards that goal through evolution. But with technology, we can do that. With technology, we can imagine what we want to exist in the world, and then we take the steps to make that happen. And therefore, we can infuse technology with our ideals, right? With our hopes and dreams, with thoughts. And my favorite example of kind of an approach to technology, a school of thought, is one called Shindogu. There was a Shindogu society founded in Japan in 1995, and it has a philosophy behind it. That this is to make tools that are not exactly useful, but not altogether useless. Okay? And I guess the best way to describe it is to just show you some of these Shindogu things, where you look at them and you think, well, that's stupid, but actually, is it? Like, I mean, it's not altogether useless, right? You look, it's like, that's crazy, but you know, maybe, well, why not? Why not keep your shoes dry in the rain? Why not harness the kinetic energy of your toddler to keep your floors clean? And if you don't have a toddler, that's fine. It'll work on other things too. But of course, the thing with these tools is you can't imagine them being used in the real world, right? There's a social factor here that isn't being taken into account. Like, I was looking through the Shindogu book from years ago, and I found this device, which is kind of this kind of stick that you put a camera on, and so you could take self-portrait pictures. But in public, I mean, I just can't see anybody ever actually using something like this. But Shindogu, pencils, toasters, Australian hand axes, they're all kind of part of the same trend, which is the trend of technologies. You have a human being that's being augmented through hardware, that the technological innovation is some piece of hardware, an axe, a pencil, Shindogu. And then something changed in the 20th century. We got something new in between the hardware and the human. We got software. So now the human can interact with the software, and it's the software interacts with the hardware, and vice versa. And I think one of the best examples of these three layers working together in harmony would be the Apollo landings, right? Took incredible hardware, incredible software, incredible humans. By the way, seeing as we were just talking about selfie sticks and selfies, I should point out this is one of the few examples in existence of an everyone elsey. This is a picture taken by Michael Collins, and we've got Buzz Aldrin, Neil Armstrong, and every human being on the planet except Michael Collins. It's an everyone elsey. Anyway, the Apollo missions, right, incredible. Actually landing human beings on the moon, just an astounding achievement. And it did take incredible human beings, incredible hardware. Right? The Saturn rocket is still the most powerful rocket ever built. And it took incredible software made by Margaret Hamilton. She invented entire schools of software engineering to make this work. And if you look at the trend of humans and software and hardware since then, you know, over time, as the software's got more powerful, the hardware begins to fade away. The hardware starts to become less and less important. And it's more about the power in the software. This idea of design dissolving in behavior, right? The ubiquitous computing, that the hardware is all around us, that we can ignore it and concentrate on just interacting directly with it. Now, this idea of the hardware becoming irrelevant, that the hardware shouldn't matter, if you think about it, that's sort of what was at the heart of the World Wide Web project. When Tim Berners-Lee was working at CERN, the European Centre for Nuclear Research. And he's there with all these scientists, and they're trying to collaborate, but CERN's this amazing place, but they've got no hierarchy whatsoever. So you can't tell people you have to use this piece of software, you have to use this piece of hardware, you have to do this. Everyone uses whatever hardware they want. And the goal for Tim Berners-Lee was to come up with some way for these people to collaborate no matter what hardware they were using. The hardware should be irrelevant. And we take this for granted today, that you can make a website. And of course it's going to work on a Macintosh, and of course it's going to work on a Windows PC, and of course it's going to work on Linux and Android and iOS. But it was actually kind of a revolutionary idea that the hardware should become irrelevant. And the World Wide Web itself is this classic example of a technology that couldn't exist without layers of technology before it. You can't have the World Wide Web without having the internet, but you can't have the internet without first having computers, and to have computers you need electricity. For that you've got to have the Industrial Revolution, right? It's just like layers upon layers, standing on the shoulders of giants. Stephen Johnson talks about this idea of the adjacent possible. That the reason why the microwave oven couldn't be invented in medieval Holland is that too many other steps needed to happen before you get to a microwave oven. And then in the World Wide Web project itself, there's these individual technologies. And none of these technologies are necessarily the best technologies, but they worked well enough, and they got the job done. And it turns out, not to belittle the achievement of Tim Berners-Lee and his colleagues, but the hard part isn't coming up with the technologies. The hard part is convincing people to use the technologies. And when it comes to convincing people, I always think of Rear Admiral Grace Hopper, amazing computer programmer, inventor of the compiler. Software engineering wouldn't be the same without her, co-creator of COBOL. She used to say, and she had this phrase to say that the most dangerous phrase in the English language is, we've always done it that way, right? So changing people's mindsets is hard. She said, humans are allergic to change, right? I think there's something to that. In fact, she used to have a strategy. She said, humans are allergic to change. I try to fight that. That's why I have a clock on my wall that runs counterclockwise, which is a really good example of something that's completely arbitrary. The fact that a clock runs counterclockwise and the numbers are arranged in that order is pretty arbitrary. I used to have a watch actually that ran like this. Kind of hacked my brain, and now I can't read regular clocks normally. But this is a completely arbitrary decision, that clocks run clockwise rather than counterclockwise. Why is that? Well, it turns out it's because of, a fluke of civilization, that sundials in the northern hemisphere would run in a clockwise direction throughout the day. If the southern hemisphere had been in the ascendant, all our clocks would run the other direction. Completely arbitrary. We're stuck with it. And on the subject of time and arbitrary decisions, why is it that there's 60 seconds in a minute, and 60 minutes an hour, and 24 hours in a day? These numbers, they aren't the kind of round numbers we're used to dealing with. Well, it turns out it's a holdover from Babylonian accounting. The base 60 was the lowest number you could divide evenly by the first 6 numbers. So made it handy for accounting, and now we're stuck with it. We're stuck with 60 seconds, 60 minutes. It would be way more logical if there were 100 seconds in an hour, and 100 in a minute, and 100 minutes in an hour, and 10 hours in a day, right? Decimal time, that would make so much more sense. Are we going to shift to decimal time? No. Why? Humans are allergic to change. People tried. Right after the French Revolution, there was an attempt to move to decimal time, and they were chopping heads off, and they still couldn't convince people to do it. It's very hard to change people's behavior, right? Luckily, at least when it comes to measurements, we do have logical ways of measuring things, right? The metric system, very logical, and most of the civilized world uses the metric system, which was introduced after the French Revolution. Of course, except your country, of course, because you've got to have your own way of doing it, your own standards, right? In fact, honestly, this is true. There is a World Standards Day. I'll repeat that, World Standards Day. It happens on October the 14th. Except in the United States of America, where it happens on October 23rd. Now, I know lots of Americans, they would love to switch to metric. They think it's much more logical. Is it going to happen? Of course it's not going to happen. Why? Because humans are allergic to change. Grace Hopper understood this, and Tim Berners-Lee understood it as well. But whereas Grace Hopper said, I tried to fight that, Tim Berners-Lee kind of went with the flow. So he made sure that each piece of the World Wide Web stack was familiar enough to people that they wouldn't be too allergic to it, right? That it was just familiar enough. So he didn't invent everything from scratch. He built on what was there before. So HTTP, the transfer protocol, is built on top of TCP/IP, the internet protocol. URLs, he didn't come up with a whole new system. He used the domain name system, that John Postel and others had already come up with. And HTML, the format, right, for putting things on the World Wide Web, he based that off an existing format that everybody at CERN was already using, called SGML, Standard Generalized Markup Language. In fact, if you were to look at the flavor of SGML, this markup language that was being used at CERN at the dawn of the web, you would have seen elements like this in the SGML documents. Body, title, H1, H2. Familiar, right? Tim Berners-Lee literally took those wholesale, just stole them and said, this is HTML now. And so this was familiar enough for people. In fact, people were able to take their SGML documents and just change the file extension to .htm, and it would work in a web browser. That was genius. People are allergic to change, and this was a way of kind of going with that flow. Of course, we didn't get stuck with these elements. We were able to evolve HTML over time, which is wonderful, right? We got more elements to add semantic richness and accessibility to the documents we were putting on the web. Where it gets really interesting over the course of HTML's history is when we get the elements that have behaviors encoded in them, right? Where browsers agree on how to treat these elements, and you get very rich interactive behaviors from these elements. But something interesting in all of these elements, right? Video, audio, picture, canvas, all of them have been designed and built in such a way that there's a way of providing fallback content, that the author can make sure to provide fallback content for any browsers that don't support these elements. Like the canvas element, classic example, right? It's for very rich scripted sort of image interactions. You can put anything you like in between the opening and closing canvas tags. Now, a browser that understands canvas will just ignore whatever you put in between those tags, but an older browser won't understand what the canvas tags are and will render whatever you put in between them. So you get fallback content, right? And that's not an accident. That's by design. The canvas element actually started life as a proprietary element by Apple. This is actually how a lot of standards get made. One browser does something and all the other browsers go, ooh, that's nice, we'll have that. So it gets standardized. But when it was a proprietary element by Apple, it was a standalone element, right? Like the image element or Meta or any of those standalone elements. But when it got standardized, they made sure to give it the closing tag specifically so we could do this, so that we could have the fallback content. Same for video, same for audio, same for a lot of these rich things. Like I said, that's not an accident, that's by design. And there are design principles for HTML. And I think they're pretty good design principles, right? The idea that these things should be designed to, web content can degrade gracefully in older or less capable user agents and still making use of these great new technologies. I like design principles a lot. I collect them. I'm a bit of a nerd for design principles. There's design principles for people, for software, for organizations. Even Chindogu. Chindogu has design principles. The web has design principles. And I think the reason why I'm fascinated by design principles is sort of where they fit in the hierarchy of how we go about building anything. So to start with, you've got the goals, like what your mission is, right? That's your goals. And then the principles are how you agree to achieve those goals, right? The agreements you're going to use. And then the patterns are what you end up with. So for example, if you're building a nation, like the United States of America, the Declaration of Independence, that's your goals, right? You've planted your flag in the sand. And then the Constitution, that's where your principles live. And then the laws that you use every day, those are the patterns. In the case of HTML, or in the case of the World Wide Web, you've got the goal of making the hardware irrelevant, right? The idea of ubiquity, universal access. The principles, well, we've got the HTML design principles as an example of those principles. And then the patterns, well, those would be the individual elements, right? The patterns that we end up with in HTML are the result of the principles, which are the result of the goals. Now, whenever you're confronted with something new on the web, a new HTML element, a new CSS property, a new JavaScript API, you want to evaluate it. You want to decide whether it's worth your while using it. And the first question you'd ask, and it's a good question, is how well does it work? So you might look at Canvas or video or audio, any of these things, and say, how well do they work? And they work okay. I mean, they're fine. They're probably not the best things, but they work fine. But I think the more important question to ask, rather than how well does it work, is to ask, how well does it fail? So in the case of those HTML elements, canvas, video, audio, they fail very well because they've been designed to fail well, because of those design principles. Right? Canvas fails well, audio fails well. So I think this question is a good one to ask when you're evaluating technology. Let's take an example. You know, we've seen a lot about CSS over the last couple of days. We had Jen showing us the amazing things we can do in CSS, like CSS shapes is a really great addition to CSS. Now, if you're deciding whether or not to use this stuff, one of the first things you might do is go to caniuse.com, type in the thing you're evaluating, and you get green or red, depending on browser support. And you might make your decision based on the amount of green or the amount of red. But this just tells you which browsers support CSS shapes. It doesn't answer the question, how well does it fail? What happens in those browsers that don't support CSS shapes? There, Caniuse can't help you. So let's ask that question. How well do CSS shapes fail when you use them? So here's an example of CSS shapes in action. I'm using shape outside circle. And see the way that the text is kind of curving around the circle, okay? So that's how well it works. Works fine in a browser that supports CSS shapes. What about a browser that doesn't support CSS shapes? Well, then I get this. The text is just in a line next to the image. That's okay. That actually fails pretty well. So I feel like I can go ahead and use CSS shapes. I'd probably go ahead and use it even if it were only supported in 1 or 2 browsers, because the lack of support isn't harmful. I'm not harming the browsers that don't support CSS shapes by using CSS shapes, because it fails well. So let's use that lens. Let's ask that question of a number of technologies you've been hearing about over the past few days, like service workers, right? We've all been hearing about service workers from Jason. So before coming here this week, who had heard of service workers? Right, quite a few hands. Now, who's using service workers? A lot fewer hands. So those of you who put up your hands, like you're evaluating it. You've heard about it. People are talking about it, but you haven't decided whether or not you're going to use it. I should probably explain quickly how service workers work, because not everyone had heard of them. They're a weird thing. It's a JavaScript file, but you don't treat it like your other JavaScript files, because it's a JavaScript file that kind of gets installed on the user's computer, almost like a cookie, but a cookie that can execute instructions, so it's like a virus, but it's a good virus. It's like you're doing a man-in-the-middle attack on your own website. It's very powerful. And it begins like this, where, just as Aaron was showing us the way, a connection is made. So you begin with the DNS lookup, and then you do the TCP handshake. So a browser is requesting a file from a server, like an HTML page, and the server sends back a response. Okay, and then that page can be requesting images and style sheets and scripts. And one of the things it can be requesting is a service worker, which, like I say, then gets kind of installed into the user's browser. And from then on, the service worker can intercept any request. So the next time that the browser makes a request, the service worker can make requests of its own accord, right? It can start getting things from the server in the background, and then you can put those into a cache. So this is the pre-caching that Jason talks about, right? So now you've got 2 places you can go to. You could either go to the network, or you could go to the cache. Your decision. You script what you want to happen. So by default, everything carries on as normal. Requests go through the service worker, and by default, everything goes to the server as normal. But you could write instructions say, no, for certain kinds of files or for certain URLs, I want you to look in the cache first, right? Try looking in the cache first. Or you could say, I want you to try looking in the network, but if that doesn't work out, we'll fall back to looking into the cache, right? So you've built a more resilient kind of website then. Or, and this is a really powerful pattern, you say, don't even try going to the network first. Try going to the cache first, and only go to the network as a last resort. So this is kind of offline first approach, where everything would be instantaneous, right? You get this huge performance boost by using service workers. And there's even a third step. You can say, try the cache first, then the network. Try the network first, then the cache. And if all else fails, here's one I made earlier, right? If all else fails, here's a fallback page. You can have your own custom offline page, just like you can have your own custom 404 page. You give people something to do while they're offline. The Guardian had this great offline page using a service worker where you could play a crossword puzzle, right? If you couldn't get to a particular article, hey, play this crossword puzzle instead. So service workers, how well do they work, right? Might be your first question. And you'd go to Can I Use, and you'd see what the browser support's like, and it's like, yeah, there's some good green, but there's a lot of red there as well, right? And that might be the point at which you stop and go, oh, not enough browsers supported, I'm not going to investigate service workers. But you'd be missing the most important question, right? Because the most important question is how well does it fail? So how well do service workers fail? And this is where I think the true genius of service workers lie. They fail really, really well. Because if you recall how that whole process started, it begins as usual. The browser has to make a request as usual, and the server has to send a response. The service worker stuff can only happen later. It can only happen once the browser has first visited the website, which means you can only use service workers as an enhancement. It's pretty much impossible to make a site that relies on a service worker. So it's the ultimate technology that you can add to a website without harming the browsers that don't support service workers, right? So it's kind of a no-brainer. Even if only one browser supported service workers, it would still be worth adding a service worker for that one browser because you do no harm to the browsers that don't support it. So what happens when a browser doesn't support service workers? Nothing. It just carries on like it normally would. No harm, no foul. So I would say service workers fail very, very well. All right, let's try another hot topic web technology. Web components. Who's heard of web components? Okay, give your hands. Who's using web components in production? Brave man. Okay. Web components are actually a weird one because it's not a technology. Web components is this umbrella term for a bunch of separate specifications. There's custom elements, this idea you can make your own elements. There's the very sinister sounding shadow DOM. There's other bits, templates, and these all get wrapped up under this umbrella of web components. And the idea with web components is that that we would finally get to do what browsers have been doing for years, right? So I was talking about the additions to HTML, and we get these very powerful elements that have behaviors attached, video, audio, canvas, picture, and so on. But it takes a while. This is more like evolution through natural selection, right? The standards process. It takes time. People have to figure stuff out. It takes a while before it settles in the browser. It's a bit slow. The idea with web components is that you could bypass all that, and you just start making up your own elements with their own behaviors. Right? You can literally start naming new elements. The only criterion is that it has to have a hyphen in the name. This is kind of an agreement between browsers and spec authors and developers like us that there will never be a future HTML element that has a hyphen. So that makes it a safe kind of namespace to play in. So you literally come up with new elements, custom elements for things you want to exist in HTML. Now, if you just start using any of these elements in a document, you might as well be writing the word span. Right? Because a browser doesn't know what to do with these elements. And that's where standards are more powerful because a browser knows what to do with canvas or audio or video. So this is the custom elements part, but the other parts of web components is that you also give the instructions on how to turn this span, effectively, into a first-class citizen. So let's say you have this mega menu element you've decided to invent. You can point it at the instructions. It used to be we were going to do this. This was HTML imports. That's kind of fallen by the wayside now, so it sounds like we're going to use JavaScript to do it. But the point is you point to a file that contains the instructions. Here's the HTML for this mega menu. Here's the CSS for it. Here's the JavaScript. And here's the crucial thing. These instructions are encapsulated. They don't leak out. So any styles for the mega menu won't leak out beyond the mega menu. Just encapsulation, that's what we've been chasing for years, right? All these frustrations with CSS are to do with specificity and the cascade and scope. And encapsulation is kind of what we've been chasing with methodologies like BEM and OOCSS, and now with the whole CSS and JS and component-driven stuff. I mean, effectively, Angular and React are trying to solve the same problem as web components, right? This very componentized approach to building things. The difference being that web components would ideally be native to the browser. Because you can't take an Angular component and drop it into a React app. You can't take a React component and drop it into a web page without including all of React. Whereas with a web component, you would get this portability. You could make a cool web component, and I could just drop it into my website. So they'd be encapsulated, and they'd be reusable. That sounds good, right? So how well do they work? I mean, like I said, there isn't one web component spec. So you'd have to look at all the individual specs and see what's the browser support like. And custom elements, oh, there's some good support there, but there's also browsers that don't support it. But as we saw from CSS shapes and service workers, the red doesn't tell us anything. The red doesn't tell us how well does it fail. So how well do web components fail? Well, this is where it gets interesting. Because the answer to the question, how well do web components fail, is it depends. It depends entirely on how you're using the web components, how you design the web components. So if you do this, right, you've just got effectively a span with nothing in it. And if a browser doesn't understand web components, tough luck, they get nothing. Now, there was this idea in web components that you could extend native HTML elements. There was this is attribute. That's fallen by the wayside. Browser makers don't want to do it, which is a pity, because this is, I think, a nice design pattern. But even without this, there's still a way to design web components so that they could degrade gracefully, just like Canvas and video and audio do, right? Because you could put your fallback content inside. Let's say you're making the mega menu. You could have your regular, good, old-fashioned menu inside it. So that's what older browsers would get. Or you're doing some cool carousel, and the images are the important thing. So you make sure you have the images actually in the markup. You wrap them in this custom element, and then your encapsulated styles and JavaScript can turn it into a swishy, animated carousel, right? So if you use web components like this, web components will fail very well. But when I see web components being used, this is what I tend to see. This is how they're actually being promoted. It's like opening tag, closing tag, that's it. That's the end. I think that's such a shame, because there's nothing inherently wrong with web components, but if we use them like this, then they fail really, really badly. Google has this project Polymer, which is kind of a library of web components and a polyfill for browsers that don't support web components. And they build showcases to show the power of web components, to show the power of the Polymer library. They built an entire shop using web components, using Polymer. And if you view the actual source of the HTML, this is what you would see. Right? There's an opening body tag, closing body tag, and inside there's nothing but opening shop app, closing shop app, and then the JavaScript is where all the action happens. That's where it gets uplifted. That's where the entire content for the page comes from. So now you've got this single point of failure. And this fails very badly. Now, the good news is it's early days yet with web components, right? This is a long-term thing. And so we could set the agenda here. We could decide that we're going to make web components that fail well. We could have design principles for web components that we would adhere to. They're very powerful. I mean, the amazing thing about web components is that they give us web developers the same power that previously only browser makers had. But the scary thing about web components is that they give us developers the same power that previously only browser makers had. And we need to match that power with responsibility, right? And if HTML has design principles for the browser makers, then maybe we should have design principles for how we build web components. And both web components and service workers kind of share a philosophy. They share principles, which is this idea of giving us access to these low-level APIs, like the cache and fetching files from the network, right? Custom elements, shadow DOM. These are things that were in the browser already, but only browser makers could access them. And now we're being given the DNA of the browser to play with. And this is the idea of the extensible web, that we can set the agenda. Instead of this long, slow, evolutionary process at standards bodies, that we make stuff up and we put it out there and we play with it, and we get the stuff we like, and then that's what gets standardized, right? So the extensible web, it's not a technology, it's a school of thought, right? Like Chindogu. The extensible web is just a phrase, but words can be very powerful. Wrapping things up in words can be the key to unlocking a technology. Ajax is just a word. right, that Jesse James Garrett coined in 2005 to describe, a whole bunch of more complex technologies, but it suddenly became so much more easy to talk about AJAX. Nice, short, snappy word to describe things. Responsive web design. It's just a phrase, but it's a phrase that has a definition, right? That Ethan gave it a clear definition. You had, fluid layouts, flexible images, and media queries. And those three things, let's wrap it up. Let's call it responsive web design. And boy, did it take off, right? By having that phrase wrapped around it. And here's a more recent phrase that you heard all about yesterday from Jason. Progressive web app. It's just a phrase. Right? It's just words. But again, people can latch onto that. Jason was talking about how, the marketing department, the boss can get excited about that. The same way they can get excited about responsive web design or AJAX. These terms can be powerful. But sometimes I worry that like Jason showing the Gartner hype cycle, we can get carried away with the term, with the words, and miss out what they refer to. Like I said, with responsive web design, I think it was really great that Ethan had a very clear definition. These are the three things that responsive web design is. And it wasn't some kind of like, oh, it's a Zen thing, it's whatever you want it to be. Right? No, very clear definition. And I think when it comes to the technology side of progressive web apps, we should keep that in mind, that there is actually a clear technological definition of what constitutes a progressive web app. And it's having your site on HTTPS, then having a service worker on that site, and having a manifest file, which is this JSON file with all the metadata, right? Here are my icons. This is the name of my site. Here's my background color. All the stuff we'd usually stick in the head of our documents, right? But all of that together adds up to this great little phrase, progressive web app, that Francis Berryman and Alex Russell coined. But the thing is, when you look at that technology stack, there's nothing in there that says, oh, then I must build a single-page app. Or, oh, I must build this in such a way that it's mobile only. Far from it. I mean, these are technologies that almost literally any website can benefit from. Like, we could all do this, and then we can all benefit from that nice carrot that Google is dangling, where people get offered to add our site to their home screens. Right now, that we're just one press away from opening up just like a native app. Very powerful stuff, and yet a lot of the sort of showcase progressive web apps that we've been looking at, I see them almost sometimes as a step backwards to the old way of having separate silos for different devices. Like, before responsive web design, we had the m.dot subdomain for mobile, right? And then the desktop for the real site. But then responsive web design shows, no, the one web is the way to go, that one URL can adapt to different devices. And with all the hype around progressive web apps, I start to see people go back to the old ways. The Washington Post progressive web app that Jason was showing us yesterday, this is what it looks like if you tried to visit in a desktop browser. A perfectly capable desktop browser that can do everything the mobile browser can, but no, we're being turned away because we're using the wrong kind of device. Oh, how the tables have turned. It wasn't that long ago you'd visit a site in a mobile browser and be told, come back with a desktop browser, come back with a real browser. Now, here I am with a desktop browser being turned away, come back with a mobile one. So I worry that maybe the hype is leading people to believe that only certain kinds of things should be progressive web apps, and that it's only for mobile and it's only for apps. But as Aaron wrote in A List Apart, any website can be a progressive web app. I've turned everything I can into progressive web app. I mean, this is a site I run that's, I guess, could be called a web app, maybe. But I've also got like an online community. That can be a progressive web app. My blog can be a progressive web app. Now, my blog is an app, I guess. I put a book online. Technically now, that book is a progressive web app. And that collection of design principles I was talking about, it's just a one-pager, but yeah, sure, I'll turn that into a progressive web app. Literally anything can and should be a progressive web app, because it is just, best practices. Now, when you're evaluating these technologies, service workers, web components, any of these, I think another good question to ask is, who benefits from this technology, right? I mean, check out the marketing for the technology and ask, who is this going to help? Because in our world, I feel like there's almost two possible answers to this question. Developers and users. There's technologies there to help developers, and there's technologies there that have direct benefit for the users. Now, 9 times out of 10, there's no conflict here. It's good for the developers, and it doesn't harm the users, or it's good for the users, and it doesn't harm developers. I would say that service workers are technology that benefit the user, right? Because that improves performance and offline experience, all of that good stuff. Huge benefit for the user. Technically, it's actually a hindrance to the developer, because now you've got to learn about service workers. right? You've got to learn how they work. You've got to program it. That takes time. So it benefits the user to a certain extent at the expense of the developer. But I think what you've got to really watch out for is when you find a technology that benefits the developer at the expense of the user, right? Watch out for that. Now, the problem is we have different kinds of technologies. I've been trying to think about how to phrase these two sort of camps I want to put these technologies into. And the best thing was that we got certain technologies are almost inward-facing, and that they sit on your computer, right? And at the end of the day, they just generate HTML, CSS, and JavaScript. So they have no direct effect on the end user. So these are like, tools, build tools, task runners, version control, pre-processors, post-processors, all this stuff, right? So when it comes to evaluating these technologies, I say, do whatever you want, because there's no direct effect on the end user. I mean, you could say there's an indirect effect, because the faster the developer works, the better the user experience, sure, but I'm talking about things that directly impact the end user or directly impact the developer. So when it comes to evaluating any of these inward-facing tools, do whatever you like. I don't care. Whatever works for you, whatever works for your team. But that criterion of do whatever you like, whatever works for you, I don't think we should apply that when it is technologies that do directly affect the end user. The technologies where the user has to install the technology in order for you, the developer, to get the benefit. So JavaScript frameworks built in JavaScript that the user has to install. CSS frameworks built in CSS that the user has to download. Right? In that situation, I don't think it's right to apply the criterion of, hey, whatever you, the developer, likes, because then you're making the user pay a tax for your benefit. And I think, you're getting paid a paycheck to do this stuff. I think the buck's got to stop with you. You got to watch out for the users. In the HTML design principles, my favorite design principle, because I'm such a nerd, I have a favorite design principle. It's called the priority of constituencies, which says, in case of conflict, consider users over authors, over implementers, over theoretical purity. Users over authors, that's us, over implementers, that's the browser makers, over theoretical purity. And I think that's a good criterion to apply when we're talking about any technologies that affect the end user, that directly touch the end user. And there's all sorts of reasons to accept or reject technologies, and we should watch out for some fallacies when we're doing that. There's one I call the fallacy of assumed competency, which is that if a technology comes from a large organization that is successful, the technology must therefore be good and will make my organization successful. So if Facebook created a tool, it must be good because Facebook created it. Or Google created a tool, it must be good because Google created it. So this idea that, if a large company is doing something, it must be good. Which is ironic, because if you've ever worked at a large company, right, you know that it's a mess. Maybe it's a bit mean to call it the fallacy of assumed competency, but maybe it's the fallacy of assumed suitability, right? Facebook's problems are not your problems. Google's problems are very different to yours. So the idea that a tool that comes from that background and is informed by those principles and goals, those philosophies would apply to you, not sure. On the other hand, I shall contradict myself here, you got to watch out for not invented here syndrome. Because they're like, well, I want to have complete control over everything, and I'm not going to use anything made by anybody else because I want to absolutely, reinvent every wheel. And that can be not great in terms of efficiency. So there's this kind of this balance between the fallacy of assumed competency and not invented here syndrome, and trying to find that balance. Now, when it comes to putting stuff on the web, what you can do, and what I tend to favor is to try and stick as close to the material as possible. HTML, CSS, and JavaScript. Or you can use these tools. And like I said, these are the inward-facing tools, so you use whatever you want, that add abstractions. So you could write HTML in an abstraction like Haml or Jade. You can write CSS in Sass or less. You can write JavaScript in TypeScript or CoffeeScript, right? And again, because these things at the end just spit out HTML, CSS, and JavaScript, I don't care what you use. Now, me personally, I don't tend to use abstractions like this. I'm a bit of a control freak, and I like to write my HTML in HTML. And I use Sass for CSS. I write my JavaScript in JavaScript. But it would be completely hypocritical for me to say that everybody should do that. Everybody should write in the material and not use any abstractions. Because these are all abstractions. Right? We're using computers. I mean, this is the genius of Ada Lovelace when she was working with Charles Babbage on the difference engine and the analytical engine in Victorian England. It was effectively a calculating machine, right? A proto-computer. Never got finished, but the idea was brilliant. And so it's doing calculations on numbers. It's a glorified calculator. And Ada Lovelace realized, wait a minute, If these numbers could be treated like symbols, so the numbers are standing for concepts, then we can do calculations on concepts. It's the same idea that Leibniz had a few centuries before, right? That you could compute with things like words, images, anything. And that's what we have today. When what we actually work with is ones and zeros, everything else is an abstraction on top of that. We aren't word processing. We aren't doing things with images in our computers. We're messing around with ones and zeros. All computing is abstraction. So that's why it would be hypocritical for me to say, oh, you have to use HTML and CSS and JavaScript because that's the real material. It's like, well, actually, no, that itself is an abstraction. Still, some of these abstractions do get you further and further away, I feel, from the road. And particularly when it's the outward-facing tools, the ones that the user has to download, I think you have to be careful. When they're very monolithic, when they're kind of all or nothing, in order to use these technologies, you have to take all the technology, right? That can be dangerous. It gets hard to cherry-pick the bits you like. Though interestingly, a lot of these big JavaScript frameworks have kind of moved to, offering server-side rendering, which effectively puts them back into the inward-facing technology camp, where they're on the server, and what gets spat out is still HTML, CSS, and JavaScript. But when you're evaluating any of these things, CSS frameworks, JavaScript frameworks, any of these user-facing technologies, you've got to have a raft of questions you're asking, right? What's the browser support like? That's a big one. What's the community like? Are you going to get answers to your questions? File size, right, that Aaron was showing us. How big are these libraries and frameworks? That's a big one. And all these are very important questions to ask. But if you really want to get down to the nitty-gritty, you've got to ask this one. What are the assumptions that are in this technology? I guarantee you there are assumptions in every technology. What you're asking is effectively, does the philosophy of this tool match my own philosophy for building on the web? Remember, they're tools. They're supposed to be helping you work faster. So if you have a tool that matches your philosophy, you work with it, you work faster. But if you have a tool that's a mismatch with your own philosophy, you're going to be butting up against it the whole time. You'll be fighting against that tool. This is how you end up with a situation. You've got a library or a framework, some kind of tool, and you've got one group of developers saying, this rocks, it's awesome. And another group of developers going, no, it sucks, it's terrible. Right? They're both right and they're both wrong because it depends entirely on how well the philosophy of the tool meshes with your own philosophy. And like I said, I guarantee you there are assumptions inside the software because that software was made by human beings, and human beings have assumptions and biases. Software, like all technologies, is inherently political. Code inevitably reflects the choices, biases, and desires of its creators. We can't help it. We talk about opinionated software, but the truth is all software is opinionated. At Clear Left, my colleague Mark has been building this open source project called Fractal, a tool for making pattern libraries. And the philosophy, the principles behind Fractal is that it should be as agnostic as possible, that it should try not to have biases right, inside it. You could use it in any tool chain, any templating language you want, any build tools you want. It doesn't make any assumptions. Turns out it's really hard to do that. It's really hard to make truly agnostic software. Every time you write a demo, you're making a choice right, about what you're going to show. That's revealing some bias on your part. But I don't want to make it sound like a technology has a way of being used and there's no way of using it other than that. Like it's somehow, the technology decides how it's going to be used. Because, we're pretty resourceful. Like William Gibbs said, the street finds its own uses for things. We end up using technologies for purposes they weren't intended for. Like, Alexander Graham Bell, he thought that the telephone would be used for listening to concerts at a distance, right? Meanwhile, Thomas Edison thought that people would use his gramophone to record conversations, record one side of a conversation, send it off, and someone would record the other side of the conversation. And those two technologies ended up being used for the exact opposite purposes to what they were intended. Or here's my favorite example of a technology that kind of found its use later. It came from Hedy Lamarr, star of the silver screen in the early part of the 20th century. She ended up married to an Austrian arms dealer start of World War II. She would sit in on the meetings. She was taking notes. They didn't pay any attention to her, but she knew what she was doing. Anyway, she managed to make it out of Nazi-occupied Austria and get to the USA, which was a whole adventure in itself. And there, she wanted to do her bit for the war effort, particularly to do with the shipping across the Atlantic after a refugee ship filled with children was torpedoed by a U-boat. She wanted to help through technology, and the Navy had this torpedo system for firing at U-boats, and it was controlled by radio. So effectively a guided missile in the water. Now, the problem was, if the enemy could figure out what frequency you were using for guiding that torpedo, they could jam that frequency, and now your torpedo just can't be controlled. So together with a musician, a composer called George Antheil, they came up with this technology based off the player piano, where the controller and the torpedo would swap frequencies at set intervals, right? And they'd be hopping frequencies all the time. And now it's way, way harder to jam that signal because the frequency is changing all the time. And you know what? The Navy never used that technology. It didn't work out. But the technology did find its own use. I see devices in the audience, and I'm guessing that some of these devices have Wi-Fi or Bluetooth or GPS. All of those technologies use frequency hopping, right? So the technology kind of found its way. You know, we sometimes think about this flow of technology like it's a tool, right? You know, we use it for however we want, but is there a will to it? You know, we talk about the history of technology, but there's multiple histories. There's different ways of looking at history. You can find different paths through the history of technology. And my favorite person for doing this, I got to meet him a few years ago, was James Burke. Did anybody ever watch Connections, the TV show Connections? Okay, one or two people who are old like me. But you can seek it out on YouTube. This amazing program. It's very hypertexty. It's very internet-y for its time. It was made in the 70s. But he would show this evolution of technology that would be surprising. Here's my favorite bit. It was the closing of episode 8 called Eat, Drink, and Be Merry. And it started with the Napoleonic invasion of Russia and how that led to bottled food, which led to canned food. And that technology led directly to air conditioning. And air conditioning led to refrigeration, which was a world-changing technology. And refrigeration, it's the same technology that led to the thermos flask. And this is where we pick it up. And we take the next step of evolution from the thermos flask.
You see, all three men had understood that certain gases ignite, and that the thermos flask permits you to store vast quantities of those gases safely in the frozen liquid form until you want to ignite them, at which point you take the top off the flask, the gases evaporate, you apply a light, and boom. Now, two gases do that better than any other. And it was Obert's assistant who put them together most efficiently. His name was Werner von Braun, and the two gases that he released from his particular version of a thermos flask, the one lying on its side behind me now, were hydrogen and oxygen. If you release those two gases into a confined space with a hole at the other end of it and mix them as you do so, and then set light to them, you get that. Destination, the moon, or Moscow.
Is that like the single greatest shot in television you've ever seen? Like there's no doing another take of that, right? Destination, the moon, or Moscow. Right? Our technology, our tools. We've come a long way. And there's even this whole school of thought that the driving force of history is technology itself. This idea of technological determinism. That technology is the driving force, and we're just along for the ride. Right? It's the future. Take it. Right? There's nothing you can do about it. All the stuff is coming. Right? Drones, self-driving cars, synthetic biology. And we get it on the web all the time, right? Oh, you know, React's where that? Why aren't you using React? VR, what's your VR strategy? Bitcoin, blockchain. Why aren't you prepared? It's the future. Take it. Right? This idea that we're just passengers along for the ride and technologies flow through history. I don't like the way that makes me feel. It makes me feel disempowered. And the ultimate expression of technological determinism is this idea of the technological singularity. Right? It's a term coined from physics and applied to technology. It was coined by Vernor Vinge, the science fiction author. In physics, a cosmological singularity is when a star collapses and its gravity is so great that it collapses to a singular point that nothing can escape from. Right? Even light can't escape from a singularity. And the point is that there's this event horizon, and there's no way outside that singularity that you can see beyond the event horizon. Now, the technological singularity, that's the idea that technology is going to rapidly change so fast that it will reach an event horizon. And there's no way that we, from our vantage point here in the present, can possibly see what's beyond that event horizon of the technological singularity. It's an interesting idea, but I think in some ways we've already had singularities in our history. Like if you think about the change from hunter-gatherers to agriculture, that was such a complete change in everything, in how we live and how we work and in how we are human, that there was an event horizon there. There's no way that a hunter-gatherer could possibly imagine what it would be like to live in an agricultural society. And then when the Industrial Revolution happened, that changed how we run our day-to-day life and how we do everything, how we gather in cities. And again, there'd be no way for someone from the agricultural world to imagine the world of after the Industrial Revolution. There was an event horizon there. But the interesting thing is that hunter-gatherers still exist. And agriculture still exists. It's not that the new revolution sweeps away what came before it entirely. It's that these things live side by side, that they live together. So technology isn't about replacing one thing with another. It is this accretion. It's things being added over time. Kevin Kelly is an author, and he writes about technology a lot. And from the titles of his books, you would imagine that they're very technologically deterministic. He talks about what technology wants, right? And the inevitable, right? It makes it sound like he's one of these people saying, like, yeah, this technology is coming, there's nothing you can do about it. But his argument is a bit more subtle than that. First of all, he points out that no technology has ever gone extinct. He doesn't mean that it's sitting in a museum somewhere. He means somewhere in the world, somebody is still using an ancient technology. Technologies just don't go extinct like that. And secondly, he says, well, while the rough shape of technology might be inevitable, we can still influence it. Looking at Luke's talk when he's talking about mobile on the iPhone, you can say from today's vantage point, oh, yeah, the iPhone, that's inevitable, right, with hindsight. But that's not true. The iPhone wasn't inevitable. Something like the iPhone was inevitable, but not the iPhone we got. Same with the web. You think, well, once we get electricity and computers and the internet, then the web is inevitable. Well, no, something like the web is inevitable, but not necessarily the web we got, right? Because it's people who make those decisions, who drive that. Looking at Kevin Kelly and his very impressive facial hair, you might be forgiven for thinking that he is Amish. He is not Amish, but he has spent time with the Amish, and he would describe himself as Amish-ish. And that he thinks we can learn a lot from the Amish, because they get a pretty raw deal. People think that the Amish reject technology, right? That it's a more Luddite approach. That's not true at all. The Amish do adopt technology, but they do it steadily, at their own pace. They are slow geeks. And I like that. I like the idea of being a slow geek, that we can adopt this technology, but at our own pace, that we evaluate the technology first and then make the decision. So I think that we could all be a bit more Amish-ish. And I don't mean in our fashion sense and our facial hair, but in asking questions of our technology. Yes, we will ask the question, how well does it work? But more importantly, we will ask the question, how well does it fail? That we're evaluating a technology, we ask, who benefits from the technology? Is it me as a developer, or is it the user that benefits? And perhaps most important of all, to ask, what are the assumptions that have been baked into this technology? Because when I look at the sweep of history, the sweep of technology, I don't see technology as being the driving force in history at all. I see that people have been the driving force of history. Now, they're remarkable people, it's true, but people nonetheless. And you know who else is remarkable? You're remarkable. So I'm looking forward to the future that you're going to make. Thank you.